Okay, so we're going to work on 10.3, generate an equivalent expressions. So, first explore activity. Identify an equivalent expressions. One way to test whether two expressions might be equivalent is to evaluate them for the same value of the variable. So I want you to go through and I want you to match the expression from list A with the expression from list B that you think it is equivalent to. So go ahead and just draw lines connecting which one in list A do you think is equivalent to list B. So you'll just draw a line, look them over, decide which ones you think are equivalent. This is just on the top part, not A yet, not section A yet. Yep, you can just look up here at the box and you can see what part we're working on. So, okay, so, okay. So we've got 5x plus 65, and over here I have 5x plus 1. Do those sound like they're equivalent? No. So I have 5x plus 65, 5x plus 5. Do those sound equivalent? Now, how about 5x plus 65, 5 times 13 plus x? It's the last one, so let's find out. The way we figure that out, we're going to use the distributive property, which is something you're going to learn here down in just a little bit. So the distributive property says that we take the 5 and we can multiply it by the 13 and by the x. So 5 times 13 would be 5 times 13 plus 5 times x. So 5 times 13 is 65 plus 5 times x is 5x. So we can rearrange this because the commutative property, it becomes 5x plus 65. So those two would be connected. Then I have 5x plus 1. If I use the distributive property, it goes 5x becomes 5x, and 5 times 1 plus 5. 5x plus 1 matches straight across there. And here I have 1 plus 5x, and because the commutative property, we can rearrange that, and it becomes 5x plus 1, connects up there. Okay, so what you're going to do now is you're going to evaluate each one of these expressions. In place of the x, you're going to use the number 3. So go through and figure out each of those expressions, find the value, write it in the box, and then match up the ones that match. So go ahead and work on that. Okay, to solve them, we just input a 3 in place of x. So 5 times 3 is 15. 15 plus 65 is 80. 5 times 3 is 15 plus 1 is 16. 5 times 3, and so we got 5 times 3 plus 1. What's 3? 3 plus 1 is 5 times 4. So like we said, 5 times 4 is 20. 5 times 3 is 15 plus 5 is... Here we have 1 times 5 times 3. 5 times 3 is 15. 15 plus 1 is... And 13 plus 1 is... 13 plus 3 is 16. 16 times 5 is 80. Good job. Okay, and so for part B, write the pairs of expressions that have the same value when x equals 3. And so in this case, you just write, the first group would be 5x plus 65. And which other one on this side? 5 times, so we'd go and 5 parentheses 13 plus 3. And then you just write out the 3 sets of pairs that are equivalent. So go ahead and do that. So for number C, how could you further test whether the expressions in each pair are equivalent? What else could we do? We could check it with different numbers. We tried it with 3 up here. We could try it with 5 and just, replace the variable with other numbers. Replace variables with other numbers. You just have to make sure you use the same number in all the equations for the variable. Replace variable with other numbers. And then for D, do you think the expressions in each pair are equivalent? Why or why not? Were they equivalent, each pair? Yes, they were. As long as you use the same variable, then yes. I'm sorry, as long as you use the same value for each variable. So as long as you plug 5 into each one of them or 3 into each one, then yes, they're going to be equivalent. Okay, I'm going to have you scroll down to explore activity number 2. Okay, so modeling equivalent expressions. You can also use models to determine if 2 expressions are equivalent. Algebra tiles are one way to model expressions. So, the small little plus sign would equal a 1. The bigger plus sign is going to equal x. So, determine if the expression 3 times x plus 2 is equivalent to 3x plus 6. The way we model it is we model each expression using algebra tiles. 3 times x plus 2, so we have 3 groups of x plus 2. X plus 2, x plus 2, x plus 2. Do you see how we have 3 groups of that? It says 3 times means we have 3 groups. And over here we have 3x plus 6, we have 3 x's, and then we have 6 1's. So, the model here has how many x tiles? 3. And how many 1 tiles? 6. Okay, so the model over on this side. How many x tiles? 3. How many single tiles? 6. Is the expression 3 times x plus 2 equivalent to 3x plus 6? Yes. Does that seem so difficult? Okay, so this, for reflect, use algebra tiles to determine if 2 times x plus 3 is equivalent to 2x plus 3, and explain your answer. So as I'm walking around, I'm going to be looking for you guys using the tiles to compare and find your answer. So be writing out, I should see some tiles and stuff written out, and checking your answer. So I'll walk around. Okay, as I'm walking around, I'm seeing some people maybe struggling a little bit with this, so I'll kind of go through it. The first one we have 2 times x plus 3. So we have 2 groups of x plus 3. So we're going to have 1 x plus 3 and a second group, x plus 3. Do you see how we got that? We have 2 times x plus 3. So I have x plus 3, x plus 3. Okay? And so is this equivalent to 2x plus 3? So I've got 2 x's and plus 3. Is it 3 for each one or just 1 plus 3? It's just 1. So see how I have 2 x's plus 3 singles. Here I have 2 groups of x plus 3. Are these 2 equivalent? No. No. The top one has 2 x's So it's going to be 2x plus 6. This one's going to be 2x plus 3. Okay, so the next part we're going to talk about are the properties. You've probably dealt with some of these properties before. If not, you're going to need to use them for the rest of the assignments today. So, the different properties that we'll be talking about is the commutative property of addition and the commutative property of multiplication. They're kind of similar. What they say is that you can have 3 plus 4 or 4 plus 3 and they're going to equal the same thing. Doesn't matter what order you add things together in. 3 plus 4 is 7. 4 plus 3 is 7. Same works for multiplication. 2 times 4 is 8. 4 times 2 is 8. So it doesn't matter what order. Does it matter with subtraction? Yes. 10 minus 3 is different than 3 minus 10. So the commutative property says you can change them and put them in either order. The associative property of addition and associative property of multiplication means that you can change the parentheses or the groups that the groups that numbers associate with. Like 3 plus 4 plus 5 will equal exactly the same as 3 plus and then 4 plus 5 in the parentheses. Moving the parentheses will not change the value. If you want to check, 3 plus 4 is 7. 7 plus 5 is 12. So here we have 4 plus 5 is 9, plus 3 is 12. So it doesn't matter. Same works. So that's the associative property of addition and of multiplication. The next one is the distributive property, and we talked about that just a little bit ago. Distributive property. Multiplying a number by a sum or difference is the same as multiplying by each number in the sum or difference, and then adding and subtracting. So, if I had 3 times x plus 2, the way I could solve that I could take 3 and go 3 times x and then 3 times 2. So that would be 3x plus 6. Another way to think about it without a variable is if this was 3 times 4 plus 2. So, what's 4 plus 2? 6. So, what's 3 times 6? 3 times 6 is 18. So now if we do it the distributive property, what's 3 times 4? What's 3 times 2? 6. What's 12 plus 6? 18. See how they come out the same way either way? That's the distributive property, and that's going to help you a lot when we're working with variables. So, the identity property of addition and the identity property of multiplication. The way I always remembered that is, do you know what your identity is? No. That's who you are, how you act. So, the identity property of addition, any number plus 0 doesn't change the number. So that number keeps its identity. Multiplication, the identity property of multiplication. Any number times 1 won't change the number. It'll stay the same. Keep its identity. You guys knew that all along. You probably didn't know there was a property of mathematics to account for it. So for example 1, use a property to write an expression that is equivalent to x plus 3. So the operation is an example. The operation is the expression is addition. You can use the commutative property of addition to write an equivalent expression. So x plus 3, you can use the commutative property and change it to 3 plus x, and then you just write commutative property of addition next to it. So example number 3. How could we rewrite number 3 using one of the properties up above? What property up above could we use to rewrite that? So the way you could do is with the associative property means it doesn't matter who's in the groups. So we have AB times C. We could have A times B, C, that would equal exactly the same, and we just call that associative property of multiplication. So now I want you to go ahead and finish 4 and 5 on your own. Okay, so I did the first one for you. We did the associative property of multiplication. The next one, we have 3y plus 4y. The answer I was looking for originally was to change that to 4y plus 3y and to use the commutative property. No, this is not written as a distributive property. This answer is not distributive right here. What we did is we did the commutative property of addition. Now, a couple students went a different route, and they did y times 3 plus 4, and they called that the distributive property. Now, generally with distributive property, we go y times 3 plus y times 4. So they did kind of the reverse distributive property. So I like that ingenuity, so I said that would be fine. But I was looking for commutative property of addition. Number 5, it's a multiplication one, so you look up top, the 3 there multiplication, associative property of multiplication. The distributive is a multiplication one, but we don't have parentheses, so we knew it wasn't going to be that, or the commutative property of multiplication, and that's what we did. So it becomes 7 times 6, commutative property of multiplication. If you're watching this video, sorry my handwriting's not so good, listen, I say it clearly. Okay, so the next thing we're going to do is we're going to identify equivalent expressions using properties. So, use the properties of operations to determine if the expressions are equivalent. So we have 3 times x minus 6, and we need to know if it's equivalent to 3x minus 6. So the first step, we got to multiply 3 times x, and we get 3x, and 3 times negative 2, which is negative 6. So 3 times x minus 2 is equivalent to 3x minus 6. 3x minus 6, are those two equal or equivalent? Yes. The other example, I have 2 plus x, and we want to know if it's equivalent to 1/2 times 4 plus x. So the first step we need to do is we need to distribute this 1/2 times the 4 and times the x. So 1/2 times 4 is 1/2 times 4. What's 1/2 of 4? 2. And then we have 1/2 times x, which is going to be 1/2 x. So we have 2 plus 1/2 x. So that's distributive property. Commutative properties, we're going to switch that around to where we have, we're trying to line it up with 2 plus x, and we have 2 plus 1/2 x. So 2 plus x, 2 plus 1/2 x. Are those equal? The 2's are the same, but we have x and 1/2 x. Are those equal? No. Not equivalent. Okay, so what I want you guys and girls to do is do this next section and solve those. Your turn. Use the properties of operations to determine if the expressions are equivalent. So you've got 6x minus 8, and you need to know if that's equivalent to 2 times 3x minus 5. And then also figure out if 2 minus 2 plus 5x is equivalent to just 5x. Okay, so let's go ahead and discuss these and find out if they're equivalent. So if I have 6x minus 8, so I've got 6x 2x minus 8. And then here I have 2 times 3x minus 5. What's 2 times 3x? 6x. And 2 times minus 5 is minus 10. Are those equivalent? No. Okay, so I have 2 minus 2 plus 5x, and then I have 5x. So order of operations, what would I do first? Is there parentheses? No. Is there exponents? No. So the multiplication is 5 times x. Can we solve 5 times x? No. So then we do addition or subtraction starting on the left. So 2 minus 2 is 0 plus 5x equals 5x, right? Because the identity problem, anything plus 0 stays the same. And the other one is 5x. Are they equal? Yep, they are equivalent. Okay, so for number 8, Jamal bought 2 packs of stickers and 8 individual stickers. Use X to represent the number of stickers in a pack of stickers and write an expression to represent the number of stickers Jamal bought. Is the expression equivalent to 2 times x plus 4? Check your answer with algebra tile models. So go through, solve this by setting up algebra tiles for each part of it, for what Jamal bought and what it's supposed to be equivalent to, and see if they're equal. Jamal bought 2 packs of stickers and 6 individual stickers. So we're going to go through and we're going to use the bar model to figure this out. So he bought 2 packs of stickers, so he bought 2, and it says to use X to represent the number of stickers in a pack, so he got 2x and then 8 individual stickers plus 8. So if we were to write that out, we'd have 2 bigger boxes, right? Yeah. And how many individual boxes? 8. 1, 2, 3. Okay, so now we want to see if it's equivalent to 2 times 4 plus x. So we need 2 groups of an x and 4 singles. So an x, 1, 2, 3, 4. Another x and 4 singles. 1. Okay, so over here I've got what Jamal bought. Over here I've got the equivalent there. So here I've got 2 big ones and 8 small ones. So I have 2x plus 8. Over here I have 2 big ones and 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. So I have 2x plus 8. Are they equivalent? Yes. Excellent. So generating equivalent expressions. So we're going to talk about some vocabulary that's going to be important as we move forward. So parts of the algebraic expression. So we have terms. And terms are each part in between, like 12 is a term, 3y squared, 4x. So anything that's connected with the addition or subtraction sign, those are the terms. Coefficients. When we have variables, the number in front of it is the coefficient. Like in this example, we have 3 times y squared, 3y squared, so 3 is coefficient. 4x, 4 is going to be the coefficient. And then like terms. Terms with the same variable raised to the same power. So 3y squared and 2y squared, in both cases y is squared, so they're like terms. If one was y and one was y squared, are they raised to the same power? Nope, so you can't combine them. If I have just 12 plus 4, you can combine those because there's no variables. But if I have 4x plus 2x squared, can I combine those? No, because I have an x and an x squared. So, okay. Okay, so when we're talking about combining like terms, we've got 6x squared minus 4x. So, are the x's to the same power? They're both x squared, so we can combine those like terms. So 6x squared minus 4x squared would be simply 6 minus 4, which is 2. And then we keep the x squared, so we have 2x squared. Because they were like terms, they were both x squared, we can combine them. So in example B, 3a plus 2 times b plus 5a. So we'll use the distributive property, so we'd have 3a, and we multiply the 2 times b and the 2 times 5a. 2 times b is 2b,